Hey y'all. Okay, we are doing dividing radicals. So we have done adding and subtracting and multiplying, and now we're doing dividing. Dividing is very similar to multiplication in the fact that you divide inside with inside, outside with outside, and they have to have the same index, okay? So if you are dividing, it says divide the coefficients, then divide using the quotient rule. So that's going to mean Rn, whatever the index is, stays the same, and then you just divide numerator and denominator, just like so under the radical house. And then it says to simplify the resulting radical. So here we go. 12 divided by 2 is 6, and 160 divided by 5 is 32. And it's still in the house. Okay, so we divided what's on the outside with outside, what's on the inside with on the inside. Now, if it's simplified, then you're done. But this one is not, because inside of 32 is 16 times 2. 16 times 2. Let me grab another color. I'm going to take the square root of 16, which is going to give me 4, and the square root of 2 stays in the house. I bring down the 6. 6 times 4 is 24. Square roots of 2. And that's how you divide. Just like that. Okay, over here, 36 divided by 9 is 4. This is the 4th root. That has nothing to do with the division. You're just dividing by, just like normal. Hold on. I can never find my calculator, y'all. It's so annoying. 1250 divided by 2 is 625. Okay, now that's a perfect 4th root. The 4th root of 625 is 5, so then you have 5 times 4, which is just 20. And so that one completely goes away. I'm going to pause you to find my calculator. Got it. So 4th root of 625. Oh, shoot. Is 5. Okay, cool. Now, moving on. Here's the letters. Okay, when you're doing this, even though it's in a radical, you're still going to follow your rules. When you are dividing like bases, you're subtracting. So, under this radical, I'm going to have x. 3 minus 2 is 1. You don't need to put the 1 there, but I'm doing that just to show you. And then 9 minus 5 is 4. This is a square root. There's no number there to index as the index, so 1 is not going to be able to come out. So the x is going to have to stay in the house. This is even. Okay, so there are 2 perfect groups within that. So that's going to be y to the 2nd on the outside and x on the inside. This is your answer. Okay, let me flip over, go to the key. Number 4. If you look here, she divides and gets 7. The index is 3. She divides to get -2, subtracts to get 5. Okay, so then you can see we split to simplify. -8 is a perfect cube. There are 3 within the 5, so you take that 3, and then you've got 2 left over. This is a perfect cube root. That gives you -2m. You multiply by the 7 that was already out there. That gives us -14m on the outside, and then the m squared stays on the inside. Over here with this one, you just divide like normal. It gives you 3. There's no way to simplify that, so that stays the same. Over here, divide here, 40. Within 40 is 8, which is a perfect cube, times 5, which is not. The cube root of 8 is 2. 5 stays there. And then, what happened? Oh, sorry, y'all. They split this. So because this doesn't divide evenly, okay, so since this doesn't divide evenly, you can tell that she took the numerator first and simplified. Then she has the denominator. Well, the denominator is a perfect cube, which is why it just equals 3, and that is your denominator. So simplify the numerator, simplify the denominator if they're not divisible. Sorry about that. Same thing with this one over here. 7 and 64 are not divisible, so she dealt with 7, x to the 5th as the numerator on the bottom. This one is a perfect cube, which gives us 4y squared. And then she just simplifies. Over here, same thing. Deals with the numerator, denominator. That gives us our answer. Okay, switch back over. I'm going to talk to you about rationalizing the denominator. Okay, now, when you rationalize the denominator, what that means is you are not allowed to have a radical in the denominator. It's just a rule that's not allowed. Okay, we talk about it a little bit in geometry. I've talked to my geometry students about that as well. I don't know how to make this little box go away, you guys. I'm sorry. Okay, there it goes. So I've talked to my geometry kiddos about it. So you may have learned about it in the past with Miss Shaughnessy or whoever taught you that, or even Miss Dean back in Algebra 1. But basically your job is just to get rid of the radical in the denominator, and you do that by multiplying by itself. When you multiply a number by itself, you create a perfect square. So, like if we look at this one, this has a 5 in the house. So if I multiply by the square root of 5, the square root of 5 times the square root of 5 would be the square root of 25. Well, the square root of 25 is a perfect square, so then you just have 5, which means there's no radical on the bottom. So that is our goal. So let's read what they say. Monomial denominators. Multiply the numerator and the denominator by the radical. Okay? Binomial denominators. Multiply the numerator and denominator by the conjugate. And remember that the conjugate is going to have the same term, first term and second term. They're going to be the same, but the sign that's in the middle, whether it was a plus or a minus, is going to change. Same expression, but opposite side in the middle. You'll see that in just a second. I'll show you that. Okay, so this is a monomial, just like what I was talking about. The radical is 5, so I'm going to multiply. I'm not worried about that 2. Okay, that 2 is fine. I just need to get rid of the radical. It's okay if there's a number on the bottom, just not a radical. Now, whatever you do to the bottom, you have to do the same thing to the top, okay? So if I look at the top, I've got 3, that's not in the house, 5, that's in the house. So those two things cannot be multiplied. I just smush them together. So 3 square roots of 5, that's my numerator. On the bottom, like I said, over here, 5 times 5 is 25, guys. 25 is a perfect square, so that's going to give us 5. So that's going to be 2 times 5 on the bottom, which is 10. Now, if 3 and 10 were divisible, you would keep going, but since they're not, this is our answer. It's fine for there to be a radical in the numerator. It's just not okay to be a radical in the denominator. Okay, with number 10, this radical has got a fraction inside. So the first thing that I'm going to do is I'm going to write the square root of 8 and the square root of 15 separate. Okay, hold on, my mom's calling me. Okay, sorry, y'all. All right, back to where we are. I just split it up. So we've got the square root of 8 and the square root of 15 separate, just like that. So it's fine. Now, 8 is fine. We're not worried about the numerator. It's just the denominator. So I'm going to multiply by itself because 15 times 15 is going to be 225. Well, the square root of 225 is 15. So that is going to just be 15. It gets rid of the radical. By multiplying by itself, you get rid of the radical. But whatever you do to the bottom, you have to do the same thing to the top. So what is 8 times 15? Well, that's 120. And that's going to be inside the radical. Okay, well, I know at least 4 is within that, so we need to find and simplify 120. Okay, so within that would be 4 times 30. That gives us 120. 4 is a perfect square. That gives us 2. 30 is not. The only factors of 30 are 1, 3, 5, 6, 15, 10 and 3, but none of those have a perfect square within it. So that's perfect. That simplifies that. 2 square roots of 30 is going to be my numerator. Then we have 15 in the denominator. 2 and 15 are both on the outside, so we could simplify those if they had anything in common, but they don't. So that's my final answer. Okay? All right, we're rocking and rolling. Let's switch over to the key. Look at the ones that are like those. Whoa, sorry. Okay, so next page you can see they're trying to get rid of the 7, multiply top and bottom by 7. That gives you 49. 49 is a perfect square, so 4 times 7 is 28. That's what's going to be in the denominator. The numerator, you multiply 4 times 7. That gives you 84. They split 84 using the perfect square 4 times 21. The square root of 4 is 2. 2 times 3 is 6. 21 is on the inside. Now, this is one that can continue to be simplified. 6 and 28 are both divisible by 2. So 6 divided by 2 is 3. 28 divided by 2 is 14. That's your final answer. Over here, this one just deals with the letters. That's totally fine. The first thing that they're doing, though, is simplifying to get rid of that A. So if you can simplify, do that first. Same thing with 28. If 28 and 3 were divisible, you would divide that, but you can't. So then you rationalize your denominator by multiplying by the square root of 3. Okay, so on the bottom, 3 times 3 is 9. The square root of 9 is 3. So you've rationalized the denominator. That's the goal. On the top, 28 times 3 is 72. So you split 72 into 36, which is a perfect square, and a to the 4th, which is a perfect square, times 2, which is not. That simplifies here. That simplifies there. And then again, you can simplify. She messed up. Her math is messed up. 6 divided by 3 is supposed to be 2. So this should be a 2 right there. A squared and then the square root of 2. Okay, so she made a mistake, but it's just supposed to be a 2. I can't write on top of that with this. So just listen to what I'm saying. That's supposed to be a 2. Okay, on number 13. If we look at this one, this is a monomial, this is a binomial, okay? So when you have a monomial on the bottom, you still just do what we've been doing. You multiply by the square root of 2, multiply by the square root of 2. That's going to give you the square root of 4, which is going to give you 2. Beautiful, perfect. Now, when you have a binomial up top, you can see she put it in parentheses, and then you're going to distribute. 2 times 8 is 16. 2 times 2 is 4. Those are both inside the radicals, but they're also both perfect. The square root of 16 is 4. The square root of 4 is 2. 4 minus 2 is 2. 2 divided by 2 is 1. So that one just really simplifies itself out. Over here, same thing, just a little bit more difficult. Multiply by itself. The square root of the square root of 12, which gives you 144. Square root of 144 is 12. So we rationalize the denominator. Up top, you distribute. This is inside. You multiply by what is inside only. So 3 just stays the same. 2 times 12 is 24. 12 times 6 is 72. Then you have to simplify each one of those because remember, you can't add unless they have the exact same thing in the house. So I simplified this using 4 and 6. You can see them over here. This one's 36 and 2. Simplify there. That's perfect square. That's 2. 2 times 3 is 6. 6 stays in the house. This one's a perfect square of 6. 2 stays in the house. Now, we can't simplify this any further as in adding them together. But all of the coefficients, 6 on the outside, 6 on the outside, 12 on the outside, are all divisible by 6. 6 divided by 6 is 1, which is why you don't see anything in front of that now. 6 divided by 6 is 1. You don't see anything there. 12 divided by 6 is 2. So this is your most simplified answer. Okay? Now, starting on number 15, that's when we have a binomial. So I'm going to come back over here and actually work that problem out with you. Okay, so let's look at number 15. If we look at 15, this is a binomial because there are 2 parts. So I am going to multiply by the conjugate. Remember that the conjugate is going to be the same expression, same numbers. The sign in the middle is going to change. Now, I'm going to do this in two parts. On the bottom, you're going to be doing FOIL. Or, if you don't like FOIL, you would be doing the area model and using that box. So, I've got 4 plus the square root of 2 times 4 minus the square root of 2. Now, once you get the trick, you really wouldn't have to do this every time because you know the conjugate is always going to have the same pattern. So once you figure out the pattern, then you can just go with it. But for now, 4 times 4 gives us 16. 4 times the negative square root of 2 would be negative 4 square roots of 2. Inner would be positive 4 times the square root of 2. And then we have the square root of 2 times the square root of 2. One of them is negative, so that would be minus the square root of 4. Now, this is what's going to happen every single time with the conjugate. Your middles are going to cancel each other out, always. So that's going to be gone. And then you're going to have minus, always, the square root of whatever this times this is, the last two things. So in this case, 4. Well, the square root of 4 is perfect, which means 2, and it should always be perfect. And then it's just going to be minus 2. So we've got 16 minus 2, which is 14. So that means my denominator is going to be 14. There's no radical. You rationalize the denominator. That should happen every single time. Now, the only thing is, whatever you do to the denominator, you have to also do to the numerator. So I also have to multiply this by the same thing. This one doesn't require us to do FOIL. We can just do the distributive property and multiply. So 4 times 4 is 16. And 4 times the negative square root of 2, that's inside versus outside. So I'm leaving them separate, just like that. I don't put those together. Now, if we look at everybody that is on the outside of this one, 16, 4, and 14, each one of those, 16, 4, and 14, they are all divisible by 2. I cannot touch inside the house. I can only do the ones that are outside. So divided by 2 is 8. Divided by 2 is 2. The square root of 2 stays the same. You cannot touch inside the house. And then that would be 7. So this would be my final answer. Let me make sure. Yep. Okay. Over here, let's do it again. If you didn't get that one, I'm going to do this one over here again. So this is a binomial. So I'm multiplying by the conjugate. So plus instead of minus. And I'm going to be doing FOIL. Okay. So I'm going to do my FOIL up here. All right. So 6 times 6 is 36. Now, I already know the middles are going to cancel out, so I don't even have to do that, okay? I know that's going to happen every time with the conjugate, so I really only have to do the last. So I really just need first and last. This is going to be minus. It should always be minus, and then you're going to have the square root of this time. 5 times 5 is 25. Well, again, that's perfect, and it should be every time. The square root of 25 is 5. So you've got 36 minus 5, which is 31. So my denominator is going to be 31. Now, like I said, I skipped the middle 2. So I'm not doing the O and I because they are going to always cancel out. Just like you saw over here, one will be a minus, one will be a plus. So instead of going through the trouble of actually doing those, I'm just skipping that and only doing the first and then the last. That's what I'm getting to get that. Again, whatever I do to the bottom, I have to do the same exact thing to the top. And for this one, I'm going to just distribute. 2 times 6 is 12. And then 2 times the square root of 5 is 2 square roots of 5. Now, in this case, 12, 31, and 2 don't have anything in common, so that is my answer. Okay? I am going to skip to, let's do number 20 together, and then I'll come back and show you the key for the others. Okay, so I need the conjugate. Again, that just changes the sign in the middle. Nobody else is changing. Everybody else stays the same. I'm just changing that there. So I'm going to do FOIL. Okay, so, but I don't have to do the O and the I. I'm just doing first and last. So let me write this out. Okay, so first would be 3 times 3, which is 9. And then last is going to be minus 4 times 4 is on the outside, so that's 16. And then 6 times 6 is on the inside, so that's 36. The square root of 36 is 6. These are being multiplied, you guys. They're right beside each other, so they're multiplied. I don't know what that is. 16 times 6 is 96. So that's minus 96. 9 minus 96 is 87. Okay? So 87 is going to be my denominator. I'm sorry, negative 87. That's kind of a big deal. Negative 87 is going to be my denominator. It's fine for it to be negative. It just cannot be a radical, which it's not, so that's fine. Then I also have to do the same thing to the top. This is a binomial, and this is a binomial. So again, I'm going to have to do FOIL. But I cannot just do the first and the last. I have to do all of them because these are not conjugates. So I've got to do 8 times 3, which is 24. And 8 times 4, because they're on the outside. So that's going to be 32. And then 6 is going to stay in there. Then I'm going to do here, which is going to be negative 3 on the outside, 6 on the inside. And then for this one, we've got negative 4, because a negative 1 times 4 is negative 4. 6 times 6 on the inside, which is 36. Now, the first thing I'm going to address is this. Okay, that's a perfect square. So that gives me 6. And it's going to be multiplied times 4, so that's going to be negative 24. Now, this is just a regular number, no radical, and this is a regular number, no radical. They cancel each other out, so those are gone. That won't always be the case. That's just this example. This could have been 30, and then you would have done 30 minus 24 and gotten 6, okay? But this is the case where it cancels out. It's just this one time. Now, we are able to add those together because they have the same thing in the house. Remember that you're able to add or subtract if they have the same thing in the house. It's like a like term. They both have x or whatever, so we do the coefficients. 32 minus 3 is 29. The 6 stays the same. 29 square roots of 6 is going to be my numerator. Now, do 29 and 87 have anything in common? Yes, I think that they are, 87 divided by 29. Yeah, see, it's divisible. It goes into that. So, if you didn't know that, which I really didn't, I just looked at my key, you could put it in your calculator. It gives you that repeating decimal, which is going to be 1/3. So 29 goes into 29 one time. You cannot touch inside the house, so that's just square root of 6. And then 29 goes into negative 87, negative 3 times. So you could just say this would be the whole thing is negative, square root of 6 all over 3. Or you could say the square root of 6 over negative 3. Okay? Any of those are fine. All right, let me switch over and show you the key for the ones that we skipped. And then I'm done with you. Okay, so what do we skip? 17. So if you look at 17, they're multiplying by the conjugate, top and bottom. Just the distributive property right there. And then on the bottom, you're having to do FOIL. She showed it, but like I said, those are always going to cancel out. So over here, that's a perfect square, which is 2. 2 times negative 16 is negative 32. 1 minus 32 is negative 31. So that's perfect. Over here, this one, same thing. You're using the conjugate top and bottom. You've got to do FOIL on the top. She FOILed everybody out. This does give you 5. So that put that negative 5 first. And then they did negative 5 square root of 3, 5 square root of 5, and the square root of 15. So you can see nobody was able to be added together, so it just left it alone. For this one, the O and I cancel out just like they're going to every time. This is perfect, which is 25. 25 is 5, and this is perfect, which is 3. 5 minus 3 is 2. So that's as simplified as that one gets. And then for 19, multiply by the conjugate, top and bottom, FOIL, FOIL, and then simplify. Okay? All right, so that is your lesson. You are going to be working on your homework that does those. So that's what you have. I didn't print out your homework, so I don't really know. Let me look and see how many's on that. Here you are. Oh, yeah, there it is. Let me open that real quick. I'm trying to decide whether we need to do all of them or just the evens and odds. Let me look. Can y'all hear octonauts? That's what my child's obsessed with right now. Okay, so all of those are just rationalizing. And then you have a couple down here. So you only have... Okay, so I'm going to make you do 15, 16, 17, and 18. But I'm going to tell you that you can just do the evens until then. So you're doing 2, 4, 6, 8, 10, 12, 14, and then 15, 16, 17, 18. So that takes a little bit off of it. All right. Love y'all. Miss y'all. Have a great rest of the day.